Good morning, good afternoon, good evening, depending on where you're at. My name is Kim Everhart. I'm a member of the marketing team here at Percona, and I want to welcome you to our webinar today. I'm really excited about this topic. We have Ibrar Ahmed, our senior software architect here at Percona, who's going to walk you through our presentation on the evolution of Postgres partitioning. Before we get started, I'm just going to do a few housekeeping items. Everybody is muted, but we welcome questions. So if you have any questions during the webinar, feel free to drop them into the questions window, and we'll save them till the end. If for some reason we run out of time and we don't have a chance to address the questions, I will gather them up and we'll put them together in a blog, which will post on our site and will also contain a recording of the session. So speaking of recordings, we are recording this and you will all receive a copy of it as well as everyone that registered. So I would assume that we can say the recording will be available in about 24 hours, both via email and then as well as on our website at percona.com. Before I get going and turn things over to Ibrar, I would like to do a sound check and a site check. So if you guys can raise your hands to let me know that you can hear me. We'll start with that. So if you can hear me talking, that would be great. I understand if you can't hear me, there'll be no hands raised, but I see some hands raised. Awesome, thank you so much. And I'm gonna put those hands down, and then if you can confirm you can see the screen, there should be a slide deck on there with the evolution of Postgres partitioning. If you can see that and raise your hand, that would be great. And it looks like everyone can see us as well. So we are good to go. So thank you again for joining us. And Ibrar, if you're ready, I'd love to turn it over to you.
Thank you, Kim.
You're welcome.
Kim already introduced me that my name is Ibrar Ahmed and I am working as a senior software architect at Percona. I have 17 years of experience in PostgreSQL world, and I authored multiple books in PostgreSQL and presenting in different conferences all over the world. But right now we don't have any conferences running around the world because of the COVID-19. So hopefully everybody is fine at his home, so that stay home and stay safe there. So let's start. The evolution of PostgreSQL partitioning. Actually, the main topic is PostgreSQL partitioning. Why I put the evolution there, because it was not implemented in one go. Postgres partitioning is coming in different versions with different flavors. Like before 9.6, we have a different kind of a partitioning. After that, we have different syntax of partitioning. And then we are adding, the Postgres community is adding new type of partitioning features and everything, performance improvement into the PostgreSQL version. So let's start. So let me explain you how I will run this webinar. I created this slides like I map all the PostgreSQL documentation with these slides. So whenever you can see my slides, you can always go to the link I have provided underneath, and you can read the documentation of PostgreSQL. And each and every topic of this slide is currently mapped to the PostgreSQL documentation. So you can always go there, you can read it, you can cross-check it with that. So it's really easy for people who are reading the documentation and want some kind of a slides to compare both of them and read. Somebody is very good in reading and somebody is very good by reading the presentations. So that's why I have created this presentation. So table partition. So in this table partition, we have 6 topics there. One is overview. The second is declarative partitioning. The third is implementation using inheritance. The fourth is partition pruning. Fifth is partitioning and constraint exclusion. And the sixth is declarative partitioning best practice. All these topics are from the PostgreSQL documentations. Overview. What is partitioning? As you all know, that data is growing very fast. I was just reading some stuff that even when we are talking about the research paper, the research paper are getting doubled every 5 years. So it's just one kind of a data. But if you see the data of Google, Facebook, another, they are gathering the data. So we are fighting for the space and managing that data. So how you manage that kind of a huge data? Like if you have a table, it's a huge table. How you can divide that table? There are two kind of you can divide that table. One is you can divide by columns. Yeah. You can store two columns in one table and two columns in another table. But here we are not we are not discussing discussing it. We will split over tables by rows. That's called partition. Like I have 1,000 rows. Then if I have 10 tables, then I can put 100 rows in each table. It's not necessarily 100, it can be 150 and 50, but it's like we are dividing the rows between the table. So it's a performance feature. Why is performance feature? First thing, it's really effective to access the partition data. How it's effective? We will discuss it later because it's just an overview. Second thing is we can remove the data very efficiently. First thing is we can access the data very efficiently. Second, we can eliminate, remove data very efficiently. Next one, the effective archiving. What is effective archiving? Effective archiving is I can store one partition in one disk and one partition in other disk. How I can create a table space and I can create a sub partition into one table space and other partition and other table space. Parallel processing. What is parallel processing? Parallel processing is if I want to access a table, if I want to insert or something into table, then I can access these multiple tables in parallel. Because if I have one table, I cannot access it in parallel. You can see that I can read the data in parallel from that table, but when I am updating that data, I cannot do that, right? So parallel access is easy, if you can see that, it's easy in partition table. So how many partitions we have? We have three kind of a partition in PostgreSQL. The first, the range partitions. Second, list partition. The third one is hash partitioning. So what is the range partitioning? When you want to divide your data based on some kind of a ranges, then you have to use the range partitioning. What can be like daytime range? That if you want to store January data in one partition, February data in another partition, March, April, May, June, and it's a date range. You have a date range of data, so you want to store as ranges of date. Then you can use range partition. If you don't have this kind of continuous data, you have a discrete list of data, so you cannot use the range there. Like you cannot use a range where you want to store data based on your states. because there is no range in states. There is a range in price range, distance range, but when you are talking about the cities, when you're talking about the states, there is no range in between. You want to store one state data in one partition, then there is no range. Then you have, this is called the discrete data, discrete list. Then you need to have some kind of a list partition. You create a list partition where this state data will store in this table partition, and this state of data store this partition. So you specify the name of the or ID of the or anything of the state and map that to this some partition table. So it's easy. And in the ranges, you specify the range. And list, you specify the discrete list. And third one is the hash partition. What is the hash partition? It's kind of a function to specify the modulus and the remainder of each partition. Like if you have two partition and you create a hash of that and take a modulus of that and a remainder, then it will specify where this information will go in which partition. So we will discuss some kind of a thing and where you want to use this kind of a partition, because it can be used any, like you want to store some kind of you have names, you have a name, so you want to store that names randomly in different partition. Like you have a 4 partition, then you calculate hash of the name and take a modulus of that, and it will give you modulus with 4, then you will get 0, 1, 2, 3, and you will store. If you get 0, then you store the first partition, 1 second partition, 2 in third partition, and 3 in the fourth partition. So we will discuss later where you have to use these kind of partitions. Like the history of PostgreSQL partitioning until PostgreSQL 9.6, Postgres already had a table inheritance feature. So using that inheritance feature along with check constraint and trigger functions, we can make it a partitioning feature. Like before 9.6, partitioning was used by table inheritance, check constraint, and trigger function. So these three functions comprise of a partitioning. So how we can achieve that, we will discuss later. So range and list partitioning is supported before 9.6 until 9.6. The actual partitioning syntax added in PostgreSQL 10. So now you don't need to create any trigger on that. So there is no need for any trigger based partitioning, but it's still there. You can use that, but another syntax is there. So it's your choice now. So now you don't need to write a trigger function. So internal PostgreSQL C function will do that for you. Still, range and list partitioning is supported with that. In the PostgreSQL 11, a default partition introduced. What is the default partition? Default partition is if you specify two partitions, like one partition will go where age is less than 10, and the second partition is age less than 20, and you have not specified any partition table which is age greater than 20. So whenever you insert data where age is greater than 20, it will go to the default partition. Again, if you have two partitions and one partition is where age is less than 10 and the second partition is age less than 20 but greater than 10, obviously, then it's a second partition and there is no partition specified other than that. So whenever you insert a data which is greater than age 20, then it will go to the default partition. Hash partition is added in PostgreSQL 11. Parallel partition scans added in PostgreSQL 11. I have discussed that when you access partition, you can use parallelism to access the different partition in parallel. Optimizer partition elimination is another feature added in PostgreSQL. In PostgreSQL 12, foreign key can be referred to the can be referenced in partition table. Table space, more intuitive ways to handle the table space assigned to the partition table. Like I have already told you that table space is a very key feature because if you want to store your partition in different disks, then you need table spaces. So you can create one partition on one table space and that table space is another disk, and one table space, another partition is other table space which is another disk. Then if you are accessing in parallel, that you can reduce IO on the disks because you have two disks now. So it's really a performance feature. In PostgreSQL 12, there are other enhancement has been done, but also there's the PSQL also enhanced that it will show the listing of partitioning in very well form. So declarative partitioning. So link is there. You can go there in the documentation of PostgreSQL and you can see what is the declarative partition. So I will explain it here. So I have not written too much text here. So for the text, you can go to the documentation and you can always go to there and read there. So here is the example. And I choose almost the same example given in the documentation. I just simplified that example, but have not changed too much because I don't want to confuse the audience. What is a declarative partition? I have discussed that until 9.6 there was a table inheritance kind of table inheritance was used for the partitioning, but after that declarative partitioning was introduced in PostgreSQL 10. It's a different syntax, a new syntax, and usually used in the other DBMS engines. So let's create a parent table. Here I have created a measurement table, and if you can see in red that partition by range is an extra word you can see here. Like I have created a table with city ID, log date, peak temperature, units sales, and partition by range log date. Means I have created a parent table which can be partitioned so based on log date. So I have already have a date column there and I am partitioning my measurement table based on log date. So now whenever I create a children table, like create table measurement 1, partition of measurement for values from start date to end date. So what I'm doing here, I'm creating a measurement table 1 where log date is in between 1st February of 2006 to 1st March 2006. So whenever I insert a data in between dates, then it will goes to measurement 1. The same, I have created a table, create table measurement 2, and I have specified a different range. So you can see here, I have a log date, which is a continuous data. So I have used a range data type here. So I can use range here. It's easy and it's logical to use range here. So I will explain it to you how we will insert, how we can see the data here. So when you describe your table, you can see I describe by \t plus measurement, and you can see in red, you can see a new words partition key range, which is a type of partitioning, a log date, and partitions measurement 1 and measurement 2, and it shows you the ranges of that table. So let's insert some data into the main table. So I have inserted a 1 rows, insert into measurement values 1 and some date and some other data. And I selected data from measurement, select static from measurement. You can see the data is here. And when I selected select static from measurement 1, because I can also select from the children table, I have inserted into master a parent table, and when I selected a master or parent table measurement 1, it shows me 1 rows. And when I selected a children's table measurement 1 and measurement 2, I can see the rows in measurement 1 only, because the date I have inserted fulfill the requirement of measurement 1, and in between the constraint I have put in the while creating a measurement 1, so date is in between that constraint. So data is inserted into measurement 1. The whole row is inserted. And there is no row in measurement 2. If you go to the right side, I have inserted another row. And this time I have inserted a row with date which fulfill the measurement 2 table. So when I selected the select static from measurement, I can see there are 2 rows, because I had already inserted 2 rows. But when I have selected from measurement 1, I can see only 1 row. And when I selected from measurement 2, I can see the second row. So there is no storage in measurement. The storage is in children table. So you can see measurement is only getting data from children table and showing you the cumulative result of both tables. So now we have inserted data into parent table, and we have selected data from parent table, and we have selected data from children table separately. Another interesting thing I want to show here, I have created an index. If you see a left side, create index, measurement index, on measurement, log date. So I have created an index on that. So when I describe measurement parent table, you can see a simple measurement IDX, B tree, log date, index is there. And when you can describe the measurement one, you can see the right side. I am describing the measurement table one. Uh, in index, a separate index is automatically created. I have not created any index for measurement one. I have created an index for measurement, and it created indexes for all the children table. You can see measurement one, measurement one underscore log date underscore IDX. And what is measurement two? Measurement two underscore log date underscore IDX. So actually there is no measurement IDX index internally. It's created a separate indexes for children table. So it's a local table for all the partitions. So keep in mind, at the end of the webinar, I will ask a questionnaire for all of you that there is a concept available which is called global index. When you create index on parent and add a global word like create global index on measurement one, it will create a global index for all the partitions. So the question is, I will ask right now, the question is how many have used global index concept in Oracle and other database, and how much it is needed, because the community is researching on that, the people are interested in that or not. So it's question because here most of you are the users. So is there any need for global index or not? Next. Now the partition maintenance. So you can drop the partition. It's not drop partition, it's drop table. When you drop the table, it will drop the partition. Like in the previous example, I drop the table measurement 2. And if you describe the table, you can see there is only one partition left, which is measurement 1. That's it. And you can remove partition, like alter table measurement, deattach partition measurement 2. And you can see by describing that the partition is removed. So what is the difference between drop table and remove partition? The difference is drop table will also drop the measurement table too and deattach that. But remove or partition only deattach measurement 2 from parent table, and the measurement table 2 is still there. You can still select the data from there. So your data will intact in remove partition, but it is no longer part of that parent table. So it's your choice. If you want to preserve your data but don't want to be part of that parent table, use remove partition. And if you want the part of that, don't remove it. And if you want to delete the data, don't want to part of that partition also, use drop table. I put that example in a different way. Like I have inserted some data, I don't want to show how I inserted the data. So let's select some data. Select count static from measurement. Okay. I have selected how many rows are in measurement. Shows me I have some rows, 1 million rows. So I have selected from measurement 1, select count static from measurement 1, it shows me it has only one row, and measurement 2 table shows me it has 1 million and one row. So if I want to delete, 100, 1 million and one rows, which is in the measurement table 2, how many ways I have to do that? One thing is I can truncate measurement 2. Second way is I can delete from measurement 2. The third is I can delete from measurement based on some where condition. All right. Then I put select count static from measurement and shows me the only one row left. So let's keep that aside. So go to the right side. I have the same data where I have 1 million and two rows in the measurement table, one row in measurement 1, and 1 million and one rows in measurement 2. Here, what I have done, I just de-attached the partition measurement. What I have done, I de-attached measurement 2. And when I selected count static from measurement, it shows me the one row left. So what I want to conclude here, it's called a bulk delete. I'm deleting a bulk of data in very fast way. Even I can drop that table. If I can drop that table, it's also very fast, but I'm just de-attaching. You can see the data is still in measurement 2, but it's not accessible from the measurement table. The data is still there in measurement table 2, but it is not accessible from measurement table because it is not part of that parent. Means measurement 2 is not children of measurement. So measurement has only one child, measurement 1. So you have done a bulk delete from measurement, just issuing a single command, and it's really fast. What kind of limitation we have with the declarative partitioning till now? There is no way to create an exclusion constraint spanning all partitions. We cannot create an exclusion constraint which is for the all partition. We have to do that for each and every partition. You cannot issue one command for the constraint that it is for all the partitions. No, you have to create a constraint for all the separately for all the partitions. Unique constraints on partition table must include all the partition key column. Why it is that? Because it's a limitation in PostgreSQL. I have already discussed that there is no feature called global index. So for the uniqueness, you cannot ensure the uniqueness between all the partitions because the global index is the feature which can be used to ensure the uniqueness across all the partitions. So lack of that feature, we have this limitation that unique constraint on partition table must include all the partition key column. By doing that, you can ensure the uniqueness across all the partitions. So before row trigger, if necessary, must be defined for individual partitions, not the partition table. Mixing temporary and permanent relation in the partition tree is not allowed. These are the four limitations. And day by day, their community is eliminating the limitation from here. But still, till now, we have these kind of limitations. Partition pruning. Partition pruning is also a performance feature. So for the description, what is the partition pruning, and you can go to the documentation and you can read there. But for here from the example, I will give you the idea what is that. The first thing, you can enable or disable this feature according to your need. So you already know that there is a setting called enable partition pruning. By default, it's on. So just for the clarity, I just put a statement set enable partition pruning is equal to on. By default, it's on, but still here. I have inserted one row in measurement table, and I have selected that row from measurement. When I count rows from measurement where log date is greater than some date, so you can see that only measurement 2 table, you can see in the red because I have explained that, so it's aggregate, just leave it. Then there is a sequential scan on measurement 2 and then the filter. You know the measurement parent table have 2 tables. One is measurement 1 and second is measurement 2. But in this query, only one table is scanned, measurement 2. Why? Because partition pruning is on, and because of partition pruning, it knows that the date 206 March, 1st March 2006 is less than second less than is 2nd March 2006, and we are log date which is in the database 2nd March 2006 is greater than 1st March 2006, and it is in the measurement 2 table. So system knows that this kind of a date is not possible to be in measurement 1, so it does not scan the measurement 1 table. So like if you have hundreds of partitions and it only scans your one partition or two partition or three partition instead of hundreds partitions, it's really good performance feature. It's called partition pruning. At your table, it's not, your partitions are only scanned when it is required. And on the other hand, let's disable it. Set enable partition pruning off and insert the same row. Select the measurement. Everything is same. Now explain count static. In the right side, you can see in the red, there is two sequential scan, measurement 1 and measurement 2. So measurement 1 scan is unnecessary. We are scanning a table which is, we already know there is not possibility that this date can be in there because it's a range partition, and in the range partition it cannot be overlapped. So when system already knows that this date cannot be in measurement 1 and still scanning that, it's a performance hit. This is called partition pruning, where your table is only scanned when it's required and it's based on your query. So declarative partitioning best practices. Just these are some key points I picked from the documentation. What you need actually when you are doing some kind of a declarative partitioning, to selection of your key column. It can be column, it can be columns. And think about it should be divided logically. But illogical division of partition doesn't make sense. So if you think because you are the best to judge your data, then you have to divide logically, and then based on that logic, you have to select the key columns and use that. And another point is you can also use columns which are mostly used in where class of your query. Like you have hundreds of queries, you can analyze your queries here. Mostly you are using where class, and in where clause log date is used. That's mean that you can divide and have partitions based on log date. So we have already discussed that deletion of data, bulk data is really easy in partition. So if you divide logically, then it's really easy to delete that. Like, let me give you the example. Like you have cities data. It's logical division that you have data of different cities. And if you don't want to use one city anymore, just delete that partition based on the city name or city ID. Remove that. So all the data of that city will also remove from that. So divide your data logically, so its removal is also very easy. So how many partitions you need? Two less? No. Too many? No. Because if you have a two less partition, that's mean index remains too large. If you have too many partition, then you are increasing the planning time because planner need to plan where to send the query. So carefully choose how many partition you need. Again, carefully choose the option of subpartition because there are chances that you need some kind of a hierarchy. So don't go too deep, but it's your choice. Carefully, but sometimes subpartition are really good in performance, but don't go too deep. What kind of a partition you want to use? Range, hash, list. There is no such kind of a rule, but you know your data, and mostly these things are derived from the data because your data is continuous data. Then range partition is good. Your data has some kind of a logical division which is based on the discrete data, and it list is good. And you have no such kind of a relation, but data is too huge. Like name, don't want to put some name in one partition, some name in second partition. Just do hash partition, it will automatically divide between the partitions. So mostly it's derived from your nature of your data. Partitioning and constraint exclusion. It's an old feature and mostly used with the old technique of PostgreSQL partitioning. In this, planner will examine the constraint of each partition and try not to scan is almost similar the pruning, partition pruning. So what is the difference between constraint exclusion is only applied during query planning and partition pruning, which can also be applied during query execution. So only difference is constraint exclusion when you are planning your query, it will be used. But for the partition pruning, when you are running your query, it can also be used. So you can use partition pruning is a better option. Constraint exclusion is not better because it we already discussed that it is used for the planning time and it is not taking care of changes in DDL when table is changed, the partition is added or not. So that's why it's kind of a problem because it by default it's disabled. So partition pruning is much better option here. Constraint exclusion only works when the query where clause contain constants or constants from other queries. So you will get the more concept of it when we go to the old concept of PostgreSQL partitioning. So implementation using inheritance. I put that the old concept later because I want to spend more time on the new thing. I don't want to go spend more time in old concept, but it's still there. People are still using inheritance based partitioning. So I want to discuss it too, but why at the end? Because I want to give importance to the latest one. The parent table, you create table, a simple table, and then you create a measurement one table, and you specify a check constraint there, which and inherits a measurement. And the second table, another check constraint with measurement. So what you have to create a parent table, you have to create a children table with check constraint, and then you have to create indexes like here measurement index idx1, measurement index idx2 on measurement 1 and measurement 2 based on the log date, which is the key column. Here you can see when you describe that measurement table, you can see there are two children table, measurement 1 and measurement 2. So next step, the fourth step, you have to create a trigger function. Like I have created this trigger function, measurement insert trigger. In this trigger, I am getting the data and applying the constraint I have created for the partition table here and inserted the value in appropriate partition. Nothing else. I'm just getting the data and based on this if condition, I'm putting the appropriate data on respective partitions. That's it. And I have created a trigger and run the trigger function. It's simple because it's a generic syntax. Create trigger before insert on for each row. Execute this function. So this is a trigger function and we are executing from the trigger. So DML, let's insert some data. Similar, no difference. This slide is almost 100% same we did with the declarative partitions. What was the difference? the different for the syntax and some steps. There you have created a parent table, a children table. That's it. Here you have created a parent table and children table with check constraint. You have created a trigger function. You have and inserted data yourself into the respective partition, and then you created a trigger to run that trigger function. And the result is same. So if you have any question regarding partitioning, you can ask the question, but please leave a comment that global index is used in industry or not. Is it required to have be in PostgreSQL or not? That's one thing. And if you ask the question, I will pick some important question and will answer here, and I will answer all the other question which I will not able to answer here on my blog post. So you will get the answer of each and every question you will ask here.
Okay, well, we did get a couple questions. If you're ready, I can read a couple of them off to you, and we can start there.
Sure.
Okay. So the first question that came through is, how can we create a list partition where partition key is not part of the primary key?
It's not a problem. You can create it.
Okay.
But the problem I have discussed it when you creating a list partition, and actually the question is why he was confused here, or the possibility is not to create here. It should be unique, because then the list, the value should be unique. Like if you have a list partition, if you have 4 IDs, then you cannot have a similar ID twice. So it's not possible. First I said, yes, you can do that. But if you think logically, why? Because in the list, the value should be unique. Value should be unique. Like you have city names. So you want to put that if the city name is this, then put data in that partition. And that city name is not unique in the parent table. How you can do that? So you need a uniqueness here in the list partition. So it's logically wrong to have non-unique constraint, because it was asking the primary key. The primary key is not issue. The issue is the uniqueness. You need to have a unique column where you should create a list partition. That's it. Next.
Okay. How do we create local indexes and global indexes?
Yeah. The question is, there is no global index in PostgreSQL. The feature is not available. I have sent a patch for the global index in the community, and community asked me how many people are using the global indexes for other DBMS. Don't have any answer for that. That's why I am asking the people here. So normally, what is the syntax of that? It's create local index and the index, and create global index and that index. But the problem is there is no global index available in PostgreSQL. Whenever you create an index on parent table, it will create a local index for all the partition automatically.
Okay. Great. We have another question. How can we create partition by range for a fable having no date column?
Oh, okay. No date column. Like if you, it's not about the date. It's about anything which is continuous, which is has the ranges. Like I have given an example of age. Like you want to store data from 1 year boy to 10-year boy. and 11 year to 20, 20 year to 40. Then you have an age column. You can create a range partition on the age. On the time, you can create on time. You can the height of the people. You can create because it's also continuous. Like people have 4 feet, 5 feet, 6 feet, 7 feet. So from 4 feet to 5 feet people, you can put them in one partition, and 5 feet to 6 feet, you can put that people in another partition, and 6 to 7 another partition, and less than 4 another partition. So it's again it's a height. So anything which is continuous, you can put into the range partition. Like the temperature, if temperature is less than 10, put them into the one partition. If temperature is greater than 10, less than 20, put them in another partition. So any continuous thing can go into the range partition. Next.
Okay. What is the difference between Postgres partitioning and MySQL 8 and Oracle partitioning?
There is difference. Previously, till 9.6, it's totally different because it's based on the inheritance, and MySQL and Oracle has a declarative syntax of partition. So now the syntax is almost same, but Postgres partitioning lay some features, like I have explained the global index, some other feature which is not available in PostgreSQL. They have some limitation there, but almost syntax and everything is now we are going to compatible with Oracle and MySQL and SQL Server or something like that, other DBMS. So syntax is almost same now.
Okay, we have time for one more question, so this will be the last one. And as Ibar mentioned, any questions that we don't get to, I will make sure that they are answered, and you will receive those answers in an upcoming blog post where we have the recording of the session as well. So for the last question is, how do you achieve the partition and use it in the future? For example, do we move the table space to another place?
Can you repeat it?
Sure. How do you achieve, oh, I think that might say archive. Now, I may have read that wrong. I apologize. How do you archive the partition and use in the future? Example, do we move the table space to another place?
What I have got from here. Sorry.
I was gonna say, I'm not sure if that makes sense or not, so I apologize if I'm reading it improperly.
Okay. Maybe he was asking that we can move the table space from one space to another, then we can do that. Whatever you can do with the table spaces, the partitions on that table space will support that. Like if you can move the table spaces, it acts like a normal table on the table spaces. So
Okay.
nothing different for the partition table. Maybe if I'm reading that question wrong, then I will read that question, and if somebody, the person can also explain that here, I will answer that in detail in blog post.
Okay. All right. So we're at the end of our time. So thank you, Abrar, for your time. Thank you all for joining us. Like I mentioned, a recording should be going out in the next 24 hours. And then everyone that submitted questions, we will make sure we get them answered, and just check our blog, and they should be there. So thank you so much, everybody. Enjoy your day.
Thank you, everybody.